Okay, so this one video, we'll do it on ECG. A lot of people ask me questions or seem to have interest in ECGs. Obviously, I cannot do it in one part. It would be too condensed. I'll do two parts and maybe three, but I'll try to stick it in two. And it's not so much learning everything about ECGs, but more an approach and the reason. So the first video will be more the reason for the approach, and then after that, the approach itself. Well, a lot of people, when they go to ECG course, all they do is show them ECGs, and it's a good way. I mean, the best way to learn ECGs is to do them all the time, but you need to have a good base to understand what you're seeing. And I've explained this technique a few times to people, and they seem to sparkle a few more lights. So I'll explain it this way. So first we'll understand what an ECG is. And basically it's a machine that reads the way electricity goes at a certain speed. So what's really important to understand is that it's one picture in time. So it's literally like, so if we make a comparison, when we put someone on a monitor, we'd be like a video camera. So you see them on constant, and the electricity goes, but only in one lead or two leads, depending on what you have put on your computer, your screen, and we'll explain why usually we choose those two versus others. Versus a 12 lead is one picture at one moment in time. So it's literally like a Kodak, so you check, and a camera, so you take that and that's it. The problem with this is that things can change between the moment that you took it and right now. So if you took it 30 minutes ago or 45 minutes or 2 hours ago, things could have changed and you won't see it. Versus on the monitor, you may see it, but you may not see it because, as we're going to see, the pictures that you're looking at a certain area in the heart, which the 12 lead looks a little bit broader. So that would be kind of a lead, and that would be more like a 12 lead. And it's really important to understand this, because a lot of people sometimes don't modify the monitor, and again we'll talk a little bit more about it towards the end of this video. So to understand, so it's a picture. It's really important because there's literature now, and when I was at the foothills, some doctors were starting to talk about even starting to order ECG 30 minutes times 3. And the reason is that they wanted to see if there was any change, even if you have old ECGs and there's nothing on the ECGs and everything. And so they were starting to, because it's relatively a cheap test. The test itself, I mean, it's maybe $1 for the page, but it's the $50 that the cardiologists charge for reading them. That becomes a little bit more expensive, but it's a relatively cheap test and can tell you a lot of stuff. And to just take one, for mostly in case of chest pain, sometimes you may miss what we call dynamic change. And dynamic change means that if ECG 1 versus ECG 2 are different, there is a dynamic change. That there are not ST elevation or there are not something. If there's any change between those, something is going on to the heart, because that means the electricity is not going at the same way. Because basically this is what we're looking at, and we're going to look a little bit more on this video, but it's how the electricity travels through each of the leads. So if there's any change between ECG 1, ECG 2, or ECG 1, ECG 3, that means that the electricity is not conducting different, therefore there's something going on. So that's the first thing. The second thing is there's basically two basic rules to understand ECGs. Is that this is the lead. So when the electricity is going towards the lead, it will be in a positive deflection. So that means that if the electricity is coming to me, that's positive. And all my ECG, the tracing will be on the positive. If the electricity is going away from the lead, it will be negative. And this works for all, it's the same concept for all leads. So it's to understand after that is where's the lead, and that way you can understand, and actually you can almost make your own 12 ECG by understanding that concept and where the electricity travels. So if the electricity is going towards me, it's positive. If it's going away from me, it's negative. So this is an important rule, and the most important rule, because then it's the basic of 12 lead. Because if you understand this, then pretty much, even if you don't exactly know what's going on in 12 lead, you'll be able to explain a little bit more what's the electricity is going. So then, let's look at, so the important thing is if the electricity is coming towards me and stuff, and this always happens at the same speed. That would be rule number 2. ECGs, if you set it up at 25, I think it's 20 seconds, millimeter per second or something like this, it's the same speed. And actually, this is a trick that you can do. If you have someone that is really rapid, so a tachycardia of some sort of sinus, a narrow tachycardia, and you don't quite know, is it an arterial tachycardia, is it a SVT, what is it? What you can do is change, so from 25 seconds you can go to 50 seconds. So what it's going to do, it's going to distance the time that so it's going to, instead of doing it faster, it will take longer to take the picture. By taking it longer, your PR interval, well, the PR that is reading will be a little bit on the longer side, and you'll be able to see more what's going on there, because narrow tachycardias, you always need the P's, because it kind of helps you do the differential. Is it is it an atrial rhythm? Is it lower? Or so you need that space. So if you can do that, then it helps. So play on the speed of the machine can help you make a kind of diagnostic. So now, and sorry about. This is a heart. It's the best I can do. So, with this in mind, when we put our leads, and obviously I'm kind of doing it a little bit different. And one there, one there, one there, one there, one there. Here, and we put those in the legs, but I'll explain that they're pretty much about the same thing. Okay, so when we do a 12 lead, is that we see electricity from 12 different ways. So that means, but it's the same electricity. This is what's important to understand. So it's the same current that it's going. So it's the one beat. If we would take that in our head, it's one beat that is going, and I'm seeing it 12 different ways. And then the other beat comes and I see it 12 different ways, and that's what gives me the electricity that is going. So to understand what we're seeing on the 12 lead, we need to understand what I'm reading. So you got 12 things to read, right? So let's write those on that. So we got AVF, AVL, V1, 2, 3, and then we have V1, V6. So I got 6 here, 7, 8, 9, 10, 11, and I forgot my favorite one, AVR. Okay, so let's start with those 3 over here, and they're part of a triangle. And I forgot the name. It's a Russian name. I think it's a Russian name. But anyway, it's the basic of this, and this is what it is. It reads the triangle that way. And what it reads So we're talking about those three right now. So lead 1, 2, and 3. So lead 1 will read the electricity going from this one to this one. That's lead 1. Actually, yeah, that's right in there. That's lead 1. Lead 2, and this is why in most of the time when we monitor someone, we will read lead 2 because it is in the most in the axis that the electricity mostly travels. So that's why we put our monitor mostly in lead 2. Is because the electricity is going like this. Is it the best one? And maybe 90-95% of the time, and we'll talk a little bit more towards the end. There is case that it would be a good thing to read other leads, and we'll see why. So my lead 2 reads it this way. So we'll take this one here. So that's lead 2. So that means from the electricity from this one to this one, but actually it's more on an axis like this. And lead 3 will read the electricity this way. So if you would look in a 12 lead, during those videos, it would be a good thing maybe to have like a picture of a 12 lead and stuff. If you look at lead 3, most of the stuff is negative. Why? Rule number 2. Rule number 2 is that electricity goes from there to there. So because electricity seems to be coming, electricity seems to be going this way, but I'm reading it in a different way. So as electricity is going away, it's not towards me, but it's kind of going away from me because I'm reading the electricity in a different angle. It will be mostly negative because the electricity is going away from me. So that's why in lead 3 mostly it's negative. Lead 2 everything is pretty much on the positive because I'm seeing the electricity coming that way. I'm seeing the electricity going this way. So that's why in lead 2 mostly it will be mostly positive because the electricity is coming towards me, therefore it's positive. So that was for those three. So AVR, AVF, AVL, it stands for augmented voltage right, augmented voltage left, L, and augmented voltage foot. So that means augmented voltage right. So why was that the right? Augmented voltage left. What's at the left time? And augmented voltage foot. So when it's down. So that means, but compared to lead 1, 2, and 3, it doesn't take two, electricity is not going between two stickers. So it's not going from here to here. Those ones, all the other ones besides 1, 2, and 3, what they're seeing is electricity in one spot. So AVR will only see from his point of view. And that's why, again, if you look in AVR, everything is negative. Because why? Look where it is. Look where the electricity is going. Don't forget that electricity right now is going like this, that way, right? So the electricity is going this way. Well, AVR is there. So that means, again, rule number 2, and that's why it's so important to understand that one, and it's so easy as well. Because electricity is going away, everything will be negative. Everything coming towards me will be positive. AVF, a part of it will be positive, but a part also will be negative, because as you can see, electricity will come kind of towards it a little bit, but then after that will kind of go up as it gets into the left branch. In AVL, a little bit the same kind of thing. Well, the electricity mostly kind of goes this way because it goes there. So AVL can kind of be a little bit different as well. So now let's talk more about V1 to V6. And again, the next video will talk about what